In this video, we're going to talk about piecewise functions. And if you look in this first check your understanding, I have two graphs put on here referring to the two different functions that are a part of this piecewise function. So if I place them both together, obviously these combined wouldn't be a function because I'll have a, it won't pass the vertical line test. As I go through, it'll cancel all the time, so it will fail all the time. So what we're going to do then is we're going to go into piecewise functions depending on the restrictions here on x. So what I've got drawn here is a obvious boundary of this x is greater than or equal to 2 and x is less than or equal to 2. So in essence what we're going to do is we're going to take this blue graph and say that it only applies up into this point. So all of this is going to be removed. And then when I'm looking at 3x minus 1, which is the red line, I'm going to say that it starts to apply here, and then I'm going to remove all of this. So what happens is the piecewise function applies when we're going at x is less than 2, going up in this line, and then once we land at 2, it's going to be equal to, this is going to be a solid dot, and then we're going to jump down here and continue. So I'm going to pause the video for a moment and remove the pieces that don't apply. So obviously the part of the red graph that is less than 2 and a part of the blue graph that is greater than 2. So here's what I have with both of the lines cut off at the appropriate boundaries. The one thing I want to point out, it says this is greater than or equal to 2, so this is why I have a solid dot here. And then on the red line, it says, it's going to say greater than 2. I think I said greater than or equal. I mean, the blue is less than or equal to, and the other one is just greater than 2, so it's going to have an open dot. So this is how we're going to graph it. But when we look at this, what we're going to do is we're going to say I want to evaluate f of 2. So obviously I'm going to put 2 in for x, but I've got to choose the appropriate function. You're not going to put it into both. What you're going to do is you're going to put it into the value that fits this parameter. Well, obviously x is 2, so that means it's in this range. It's less than or equal to 2. So I'm going to only evaluate it with this number. So 2 times 2 minus 5 is equal to -1, which is exactly what we got if we went f of 2 is -1, which is this point right here. So when I'm evaluating f of f of +1, well then this one again is still less than 2, so I'm still going to use this function. So we have to decide where this x fits into which range, and then we evaluate. So I've got f of 1. So 2 times 1 minus 5 is equal to a -3, which is that point right there. So if I'm looking at the next graph, I've got several things. So the first thing I can do is just evaluate. Well, I want g of 0. So looking at which one, oh, g of 0, 0 is in that range. So this function is what I'm going to use. So I'm going to go 0 squared minus 1 is equal to a -1. So we're not just plugging into one function, we have to determine which piece of the piecewise function is actually getting evaluated. So when I'm looking at -4, -4 is right here. So when it says when g is -4, g of x is simply equal to 1. Now this is supposed to be g, so g of 2, g of 2 is right here. So this is going to be 2 times 2, and I'm going to be using that function there. 2 times 2 minus 2 is going to be equal to 2. Now graphing it is going to be a little bit different because I've got so many different things. So the first thing I'm going to look at is the graph. I'm going to graph this one black. This is x plus 3, but I only want it up until a -5. So if I want to look back, this is plus 3, and I go over 1, over 1, up 1, so it goes in a positive direction all the way. But I've got to creep back until I hit x equals -5. So this is the first place that it's equal to. I can also start making my chart, my x and my y. So I can have -7. I'm picking values that are less than negative or equal to -5. So -7, -6, -5. And then plug those values in. So -7 plus 3 is a -4, -7 plus 3 is a -3, and -5 plus 3 is a -2. So then I can plug those values in. Now as I realize I started at actually 4, so I've got to back that up like, oh, those points don't match up. Well, it's because I started a little too high, so that should be 3. And then we back that up. And then that lands at that -2 that I found right here. Okay, so let me graph that line. And that's going to be that portion of the line. So we've got that portion. And now we're going to graph g is equal to 1. Well, remember, if g of x is equal to 1, that's the same as y is equal to 1, so I know that's going to be my horizontal line. So that means that I'm going to go up, and I'm going to make this a different color. Make this my red graph. I'm going to erase all this, get this out of the way. So if g is equal to 1, that means going up here, that means it's going to be open, because if you notice, it says it's greater than but not equal to. Get these points out of the way. And then it's going to be going at -3, excuse me, -4, -3, and -2. So let me draw that line in. And then I have that little piece of the graph. Now, if you'll notice, I have here, there's going to be an open dot at -5. It's going to be a closed dot at -2, because again, I have the greater than or equal to. I also kind of reminded myself that at -5, this jumps up to 1, so that's where the open dot is going to be, but the actual f of -5 is still staying in that first range, so it's going to be 2. But that was just kind of, this here is my little note to remind myself where to jump. So the next one I have is x squared minus 1. So then we're going to take, let me extend this table down, and then I'm going to do, let's do this in a green just to make it different. So I'm going to use the points, and I'm still going to use -2, so I'm going to write -2 just as a little aside to remind myself where that goes. And I've got -1, I've got 0, and I've got 1. So then I'm going to put the values in, and I'm going to graph those pieces. So then I have these points here, and if you notice, at -2, it's supposed to jump up to 3, but remember, it's not equal to according to my inequality. And then it goes down to 1, 0, and then up to 1. This is not a perfect graph. But again, it's just pieces of each function depending on these ranges here. And so the last thing I'm going to do is I'm going to do a different color. We knew this was my green, so let me choose blue. And then we'll graph this one here. And again, I'm going to go from 1, so I'm just going to kind of remind myself where that should go. Then I'm going to choose 2 and 3. This is a linear, so I only need a couple of points to create that. So I'm going to do that just now. And here's the last piece with the blue line. Again, this is, what's nice is that they both, the green and the blue, both have the same value for x is 1, so they're continuous at that point. So this is how you graph piecewise functions. You just graph them according to every chunk of that particular interval. And then choosing what the value of the function value is all depends on the x and where those values fall.